Start. Hello everyone, my name is Barry from Barry Science Lab. Today we're doing another GRE math test practice test. So here we have question 48. So this is one of those 1, 2, 3 problems where you have to choose which ones are false and which ones are true. So let's see what they are. Let f be a real valued function defined for all R2, which means that it's a surface, and consider the graph of z is equal to f of x comma y in xyz space. Which of the following are true? If all the level curves of f are parallel lines, then the graph is a plane. If partial f partial x and partial f partial y exist for all x, y, and R2, and both are constant, then the graph is a plane. 3. If partial fxy and partial fyx exist for all x, y, and R2, and both are identically 0, then the graph is a plane. So which one is it? Well, this just depends on your ability to come up with counterexamples. And for 1 and 3, there's a counterexample that works spectacularly well. What is a level curve? Well, it's a curve that is the solution to f of x comma y is equal to y naught for some constant y, or for some constant y naught. So, what does that mean? Well, if we have, for example, this parabolic or paraboloid surface, then the level curves will each look like a circle. And so, I guess I can make this look a little bit nicer. So, what are we going to come up with as a counterexample? Well, just come up with something where partial f partial y is equal to 0. But partial f partial x is equal to something totally different. That way, the level curve is just a line. Why, you might ask? Well, if partial f partial y is equal to 0, then that means that the function doesn't... Oh crap. It should be the other way around. So if partial f partial x is 0, that means the function doesn't depend on x at all. So that means that no matter what you change x to, then the function will still always be at y naught. And so, like for example, think about a function that might look like this. I mean, this is certainly not a plane, but it's only dependent on y. It's not dependent on x, as you can see. It's exactly the same if you only travel along the x direction. And as you can see, all of these are parallel lines. All of the level curves are parallel. So that means that 1 is incorrect. And in fact, same thing holds for 3. If partial f partial x is equal to 0, then clearly partial squared f partial x partial y is equal to 0, or partial y partial x. I mean, if you take the derivative of 0, it's still 0, you know. And partial f partial y partial x partial y could very well be equal to 0 as well, simply because the function doesn't depend on partial x. This one counterexample, like, I don't know, e to the y squared or something, works on both of these. But 2 doesn't have a counterexample. If partial f partial x and partial f partial y are both constant, then the graph is a plane. Well, if partial f partial x is constant, like, I don't know, 7, and partial f partial y is constant, I don't know, 2, the graph of a plane is always ax plus by plus c, where a, b, and c are constants. So that means the partial derivative with respect to x is a, partial derivative with respect to y is b. There is no other function that just gives you constants for their derivatives. Why? Well, z is specifically a combination of the first degree term of x and the first degree term of y. The first degree function is the only function that will give you a constant as soon as you take its derivative. Well, aside from constants themselves. So that's exactly why 2 is the only correct one, which means our answer is B.